So as we close in on the end of our review chapter, there's a handful of related things and non-related things that we have to cover. So one of the first additional concepts that I noticed that people struggle with is when we're given an equation set, and we'll see this when we're talking about optimization, and we have to solve for a given variable when many are listed. So for example, this first one says, solve the following equation for A. And what we want to do, if we're going to do this, is first get the term that has the variable that we want on one side. And then we are going to subtract the y over b and the z over c to the other side. So we have 1 minus y over b minus z over c. And now I can multiply both sides by a, which would give me x equals 1 times a is a minus ay over b minus az over c. Well, the GCF, if we wanted to, is just simply keeping that a factored out, 1 minus y over b minus z over c. That's all equal to x. So we could say common denominator, which would be bc. So this would be a times bc over bc minus yc over bc minus zb over bc. And the reason why we're doing this is once we get a common denominator, we can write this right side as one fraction. So that would be a on the outside, and then we would have bc minus yc minus zb all over bc. And once we have a fraction on one side, we can just multiply by the reciprocal. So we'd be left with x bc over bc minus yc minus zb. This is the type of work that it just takes a little practice. You've probably done this in a couple of your science classes where you're solving for a particular variable. I always think of PV equals nRT, but it's just isolating a variable. So again, solve for A. So the first thing that I would do here is I want to distribute that 2 to all of the terms inside the parentheses, BC plus 2CA. Then whatever has an A is going to stay on one side. Whatever it doesn't, we're going to subtract on the other side. So V minus 2BC is equal to 2AB plus 2CA. The next thing that we're going to do is we're going to factor out the A because that's what we're solving for. We could factor out the 2, but it's not really going to get us where we want to be. So if I bring out the A, I'm left with 2B plus 2C. And now I just divide by that term on the outside. So I'm left with A equals V minus 2BC in the numerator and 2B plus 2C in the denominator. We'll do one more. So given the area, this is the area of a cylinder where we have 2 circles and then the wraparound part, which is why it's the circumference times h. That's r. Let's say we're solving for r because radius is positive. So first off, we are looking for r on either side. So we're going to divide by 2 pi. So we are left with r squared. So we have a over 2 pi equals r squared plus rh. Now, if your brain is starting to go to completing the square, you're right. We're going to take this middle term, take half of that, and then square it. So this h is the value we're taking half of. So half of h is h over 2. H over 2 squared is h squared over 4. That's how you complete the square when you're dealing with a variable. Why do we do that? Well, now we have a over 2 pi is equal to parentheses, r plus h over 2 squared. That's the beautiful thing about completing the square. As long as I remember, whatever you do to one side, you do to the other. So since we added h squared plus 4, I have to add h squared over 4 to the other side, just to make sure everything's on the same up and up. So we take square root. And since it says positive, we don't have to write plus or minus. So we're left with r plus h over 2 equals the square root of a over 2 pi plus h squared over 4. And then all we have to do is subtract the h over 2 term. So that would leave me with negative h over 2 plus square root a over 2 pi plus h squared over 4. I think you're starting to get the pattern of this, but feel free to do D, E, and F on your own. We can go over those in class if need be. The next most important topic that will directly relate to what we're going to do with limits and derivatives is this difference quotient. Difference meaning subtraction, and quotient meaning division. This is a fancy way of saying the slope of a function. Now, you might be like, Mr. Swenson, I don't really know what you're talking about. Let's say we had some function here. Let's just call that f of x. If we're looking at two different points, let's say this is at x, and then the second point is some distance h away. So we'll call that x plus h. The y values are the x, comma, f of x, and then the second one would be x plus h, comma, f of x plus h, using our function notation. If I asked you to find the slope between the two of them, we'd take the difference in the y values, and we divide it by the difference in the x values. Well, the only thing that's in the difference quotient that's different is if we had x plus h minus x, the x's go away, and we're just left with h in the denominator. So what we're going to do is we're finding this average rate of change of a given function, aka finding slope. And you should have seen this in Chapter 2 from pre-calculus, but we're just going to practice it like we haven't done it again. And I do this in 4 steps. So step 1, I want you to find what f of x plus h is equal to. So what this means is wherever you see an x, we're going to write x plus h. And then we're going to distribute that term. So we'd have 2x plus 2h plus 3. Step 2 is we would subtract the original function from what we just found. So I have 2x plus 2h plus 3 minus 2x plus 3. Well, if we distribute that subtraction sign to both terms, I would have minus 2x minus 3. And now we just simplify. We have negative 2x, positive 2x, negative 3, and positive 3. Let's make sure that I write this correctly. So I'm left with 2h. And then the last step would be write out what f of x plus h minus f of x all over h is. So we take what we found, 2h, we divide it by h. If you do this right, an h term will cancel out each time, and we're left with 2. If I asked you originally, what's the slope? All of you will clearly tell me that the slope is 2. So our work matches that the slope using the difference quotient is 2. Well, that works great for linear functions, but what about functions that are not linear? And this is this type of analysis that we're getting into. So we're going to follow this 3-step, 4-step process. So step 1, we're going to identify what x plus h is. So wherever we see an x, we're going to write x plus h. Here, we don't have to simplify. Step 2 is we are going to subtract our original function from what we just found. So this would be 1 over x plus h plus 1 minus 1 over x plus 1. Here, we are going to have to get a common denominator. So I need to multiply this by x plus 1, and this I'm going to multiply by x plus h plus 1 to the top and to the bottom. If this looks like simplifying fractions, it's because it is. So I would have x plus 1 minus x plus h plus 1 all over x plus 1, x plus h plus 1. Now, I'm just going to do a little work here. If I distribute that negative, I have minus x minus h minus 1. The x's go away, the 1's go away, and I'm left with negative h over x plus h plus 1, x plus 1. So step 3, we are dividing that function by h. Well, dividing by h is the same thing as multiplying by 1 over h. So I have negative h, my denominator. I'm just going to rewrite again, times 1 over h. The h's, again, simplify out, and we are left with the answer to our difference quotient is negative 1 over x plus h plus 1 times x plus 1. This is something that you just have to practice, and so we're going to do one more of these. And then we're going to stop there for this video. So I'm just, again, going to write out the difference quotient, at the top, so we have this as a reference. So step 1, wherever we see an x, we're going to write x plus h, and we are going to expand this out. Now, please do not make the freshman mistake. Do not say this is x squared plus h squared. You are all smart and capable young adults, and you'll know that if you want to, you can always write it twice and FOIL it. Or the fast way is square the first term, multiply the 2, and double it, square the last term. Step 2 is we're going to subtract our original function from what we just found. So I have x squared plus 2xh plus h squared minus x squared. Those go away. Step 3 is I'm going to write this whole thing out over h. So I'm going to take what I was left with, which is 2xh plus h squared over h. Now, on top, I'm going to factor out the GCF because I want that h in the denominator to simplify out. And we are left with 2x plus h. So again, difference quotient, it's going to be on, there will be at least one question of the difference quotient on your test. Please make sure that you're able to do this type of algebra quickly. So we have one more video. We're going to do some story problems and piecewise functions, everyone's favorite, and then we are done with the review chapter. See you in the next one, Falcons.